Okay, learners, welcome to one day exam prep with Polite. So on this lesson, guys, I want us to look at Newton's law question, and this is question 2, May, June 2024. So this is from the sub-exam, but trust me, if you are doing grade 11, this is the best lesson for you. And if you are doing grade 12, this is also the best lesson for you. So now let's look at the statement there. They say that block A of mass 4.1 kg is connected. So most of the time they'll just give you what you see on the statement. As you can see, they'll just tell you all the things that you see on the statement, but please make sure that you understand everything. Okay, so we're going to work on this question. And if this is your first time watching our lessons, please make sure that you join the family, subscribe to the channel so that you don't miss the next lesson. All right, so we can see what we have on the block there. They say that block A, it's at rest on a rough horizontal, and block B hangs vertically as shown in the diagram. The force F of the magnitude 49 Newton is applied on block A at an angle of 50 degrees to the horizontal, causing block A to accelerate to the left from rest along the table. So the kinetic coefficient of the friction between the surface and the block A is 0.35. I'll just come back to that information if we need it. Let me dive into questions. So the first question, they want you to state Newton's second law in weights. Guys, I can't do this with you. Please trust me. You don't need me for the definition. You have the definition on your exam guideline. Just go there, practice the definition. I'm only interested in that 2.2, 2.3.1, 2.3.2. Please go and read Newton's second law. What I'm going to tell you about Newton's second law is that F net, it's equals to ma. That's what you're going to learn from your definition, that F net is equals to ma. So now they say draw a label free body diagram showing all the forces that are acting on block A while it accelerates to the left. Okay, so now I'm just going to answer my 2.2 here. I need to draw a free body diagram indicating all the forces. So I can see that I have a tension going in that direction. So if this object is moving to the left, the frictional force will go to the right. So this will be my Fk, the kinetic friction, because the object is moving. So far I have two forces that I've indicated. Look at this. If the question is 5 marks, this tells you that you need to indicate 5 forces. So far we have 2. We know that this is in contact with the surface. It will have what? A normal force acting up, and the force that is opposite to normal force is the weight. That will be the weight. We have 4 forces. The last one, it will be the applied force. So if I draw my free body diagram, it will look like this. The tensional force, and then we have the Fk, and then we have the Fg pointing down, which is the weight. Then we have a normal force going up. That's my Fn. And the last one is the F applied. Please make sure that you get that right. That's it. You'll definitely collect all the marks. And now they want us to, I think this is going to be the longest lesson I've ever made. I think this is going to be the shortest, not longest, but the shortest lesson, because now already we're going to 2.3.1. Okay, let's look at this. They want you to find the kinetic frictional force exerted on block A. So first thing first, if they want the kinetic frictional force, we know that the formula for kinetic is Fk is equals to the coefficient of kinetic. We need to multiply that by the normal force for block A. Ladies and gents, Please note something. When you look at this diagram, the force is pulled at an angle. So if the force is pulled at an angle, and if the force is pushed at an angle, and if the force is applied horizontally to the surface, so just know that all these cases have different normal forces. So for example, if the force is not pulled at an angle, one thing I need you to understand is that the normal force will be equal to the weight. That's why we say if I have an object that is on a horizontal surface, the normal force is equals to the Fg, only if the force is applied horizontally to the surface. So my normal force is equals to mg. But now, if the force is pulled at an angle, I need you to note that there is a vertical component that will reduce the normal force. I hope this makes sense. Now, there is a vertical component that will reduce the normal force. So let's try to make this make sense so that everyone can be happy, especially if you are watching the lesson today and you are writing tomorrow. So let's make sure that you understand this today. So we're going to have a force that acts up. This is my Fy, and I'm gonna have a force that goes in that direction. This is my Fx. Remember, these are my components. So now look at this. How many vertical forces do we have now? 3 of them. So look at this. So to work on that, to answer that 2.3.1, I'm going to say for 2.3.1, look at what I'm going to do here. I'm going to work out the magic 2.3.1. First thing first, I draw all the forces, all my vertical forces, Fy. Let's indicate another one, which is my normal force. Then there's another one going down. This is my Fg. These are all the vertical forces. 1, 2, 3. So now remember, we can add this, say the normal force plus the Fg plus, okay, let's not do this because if I do this, this will be total wrong. First thing first, I need to choose direction up as positive, meaning that all the forces that are going up will be positive. So this will be my normal force. Its up is positive. We added this with the Fy, which is also up is positive. Then we subtract Fg, which is the force that is going down. We equate this to 0. Therefore, what is my normal force? Because we are trying to calculate normal force. Look at this. We have the coefficient of kinetic friction. It was given as 0.35. We have that UK. It's given as 0.35, but we need to calculate the normal force. So we said that if the normal force, if the force is applied at an angle, there's a vertical component that reduces the normal force. So my Fn, it's equals to, look at this. The Fg comes this side to be positive. This will be Fg minus the Fy goes to the other side to be negative. So this will be minus Fy. So now, what is this equals to? This will be Fg, remember, is the mass times the gravitational. So my normal force is just mg minus Fy, it's F applied, the sine of theta. Please make sure that you keep that in mind, because if I'm looking for Fy, which is my opposite, and I have my hypotenuse, what am I going to use? According to SOHCAHTOA. According to SOHCAHTOA, we have opposite and hypotenuse. This will be the sine of that angle. It's equal to opposite, which is Fy over your hypotenuse. So it's opposite Fy over hypotenuse, which is F. So to make Fy subject of the formula, I'll multiply this by F, that by F. Therefore, what is your Fy? Is just F, the sine of theta. But we are not here for the basics, right? Let's just work on this. So now, this tells you that to calculate this 2.3.1, this is what we should write on the paper. We're going to say for 2.3.1, the kinetic frictional force is equal to the UK times the normal force. But now it's easy because you know what is normal force. It's mg minus f, the sine of theta. Guys, if the force is applied at an angle, it's always in that case. And then now, remember, this one, it's when I have an object like this and the force is pulled at an angle, okay? Right. So if you have an object like this, let's say, because remember when you watch my lessons, this tells me that you are preparing for an exam. So I need to prepare you for the all scenarios, all the possibilities. So let's say they change and apply the angle, they push. So this one is pulled and this one is pushed. So if it's pushed, the normal force, your Fn, it will be the opposite of that. It will be mg. Instead of subtracting, this will increase the vertical component. This time it will increase the normal force. So this will be f, the sine of theta. I need you to keep that in mind. If the force is pulled, you say mg minus f, the sine of theta. If the force is pushed, you're going to say normal force is mg plus the sine of theta. So let's do the substitution. What is this equals to? UK, it's given as 0.35. And then we have the mass of block A. So when I look at this, block A is 4.1. So I'm just going to substitute my mass as 4.1 multiplied by the gravitational force 9.8 minus F. What is the applied force then? 49 newtons. So I'm just going to put 49 newtons there, and the sine of that angle, and the applied force is applied at 50 degrees. So this will be the sine of 50. I need you to put that on the calculator. Don't make any mistakes, okay? So we have 0.35. Now inside the bracket, we need to take the 4.1, multiply that by 9.8. Okay, let's put the 9.8 inside the bracket. Then, whatever answer that we get from those two, we need to subtract. I know that we might get the answer wrong because of these brackets, but it's fine. Let's continue and see if what we get. Then we might get an error. It's 49. I think it will be a good thing if we get an error, because you guys will learn how to fix that error. So the sine of 50. Okay, so this gives me 0.93 if I round it off. Therefore, my frictional force, the kinetic friction is 0.93. Then you are done. You'll definitely get that 3 marks. So I'm very sorry for going all the trouble explaining the normal force, just in case if you already know this. But if this is the first time you see something like this and you are writing an exam tomorrow, I guess today it's your lucky day. So now let's work on this one. 2.3.2. They say calculate the acceleration of the block A by applying Newton's second law to each block separately. Let's start with block A. Ladies and gents, you know what you need to do. When you do Newton's second law, you need to draw the free body diagram first. Indicate all the horizontal forces. Is the T and the Fk and the Fx. So there's only 3 forces that are acting horizontally. So you need to include them like this. The tensional force, then the Fk, then the Fx. Remember, this is going to the left. So we need to take that left as positive, meaning that if we say F net, it's equals to MA. We're gonna take all the forces to the left, we subtract all the forces to the right. Equate this to MA and do your substitution there. So remember Fx, it's the horizontal component. If you still remember, we said Fy is the vertical, which was F the sine of theta. The horizontal will be F the cos of theta. Okay, so maybe we can just write this and say this is F the cos theta minus UK times the normal force, which is the frictional force, minus T, is equals to MA. So I'm just going to substitute my F is 49. This will be the cos of 50 degrees. We minus, already we know what is Fk. We just calculated Fk to be 0.93. So I'll just substitute that at 0.93. Minus tension, it's equal to the mass for block A. We say this is block A, and the mass, we can see that it's 4.1. Okay, so the mass will be 4.1. Acceleration times the acceleration. Then we just have to punch all that in the calculator and see what we get. What do we get when we put this inside the calculator? So let me quickly put that on the calculator and see. 49 multiplied by the cos 50. Then we subtract 0.93. Okay, this gives us 30.57 if we round it off. So this tells you that this is 30.57 minus the tension equals to 4.18. You know what I'm going to do? I'll bring the tension this side to be positive, the 4.18 this side. Therefore, this will be the tensional force, it's equal to 30.57. Let's subtract the 4.18. Call this equation 1. Right. Now that I have equation 1, I need to do what they said, use Newton's law on each block. So now my focus will be on block B. I need to draw the, you see, on block B, we're going to focus on the vertical forces, which is the tensional force and the weight. There's only two forces, the tensional force and the weight, since it's hanging. So remember, we set left as positive. So this is one of the mistakes that you guys make. If you take left as positive, this tells you that this thing is moving in that direction. So if you take left as positive, you are forced to take up as positive. So now this tells you that for this one, we have up to be positive. So you draw the free body diagram, tensional force, the Fg, then we use F net. F net, it's equals to, okay, let me, okay, so we are saying that F net, I just wanted to fix this. Okay, so F it's equals to MA, and we set up as positive, tension minus Fg, it's equals to MA, is the same as tension minus the mass times the gravitational force, it's equal to MA. So now I just have to substitute what I have. Tension minus the mass of block B is 2.3. So this will be 2.3 multiplied by 9.8. It's equals to 2.38. We are making tension subject of the formula. So whatever that we get on the calculator when we say 2.3 It's 2.3 multiplied by 9.8. And this gives us 22.54. So this gives us 22.54. So this will be the tensional force minus 22.54. It's equal to 2.38. So what will tension be equal to? 2.38. We add that 22.54. This will be my equation 2. So what can we do with the information that we have now on the board? So this is easy. We know that tension is the same, right? So what I'm trying to say is that if I call this T1 and I call this 2T, T1 is equals to T2. So we can equate the two and solve that acceleration that they are looking for. So now what I'm going to do, I'm going to say equation 1 is equals to equation 2. So equation 1 is 30.57 minus 4.18. Equate this to equation 2, and what is equation 2 equals to? So equation 2, we just found that this is 2.38. Then we minus that 22.54. Okay, I'm very sorry about that, but please just keep in mind that it's 22.54. So I'm just going to bring it this side to group the like terms. 30.57. We're going to add that to 2.54. Okay. Equate this to 2.38. We add this one will go to the other side to be positive, right? So this is 4.18. So let's first add the left-hand side. The 30, the 22.54, so I'll say answer, I'm going to add 30.54. What is this equals to? This gives us 53.08. It equals to, then I also need to add the other sides. So it's 2.3 plus 4.1. So I think you guys can see how easy it is for you to collect the marks. 2.3. We need to add this with 4.1. Okay. This gives us 6.4. So this is 6.48. Divide both sides by that 6.4. Divide both sides by that 6.4. Therefore, the acceleration is equals to 53.08. Let's divide that I'm very sorry about this. 0.8. Let's divide that by answer. This gives us an acceleration of I just want to confirm something. We set 30.57. Okay, I just want to fix something here. If you still remember, equation 1 was plus 22 points. So this is plus. So when it comes this side, it becomes negative instead. Okay, right. Let's confirm other things. So I think, I'm not gonna stress when I make mistakes because I know you guys will learn from my mistakes. Okay, so this will be plus. So we need to say 30.54 instead. 30.54. Let's divide that. Okay, let's say 30.54 we minus 22.54. And is this not 30.57? I'll definitely fix that now. So it's 57. So I think you guys can see how easy it is to lose marks now. 22.5, and now this is 22.5. I need to fix this and say this is 30.57. So this gives us an answer of 8.0. This is 8.07. So remember, we need to take the 8.07. So we need to take the 8.07 and divide that by 6.4. Divide answer 6.4. I thought we're gonna have the I thought our lesson was gonna be short, but it's fine. So this is 1.26 if we round it off. So the answer, the acceleration is 1.26 meters per second squared. I hope you guys are happy with how we got to that. Even though we made mistakes, I hope you guys really learned from this lesson. And if you really enjoyed the lesson, please make sure that you hit on the that subscription button, and I'm looking forward to see you guys on the next lesson.